There are millions of Java developers in the world, but only 329 Java champions. Java champions are leaders and visionaries in the Java community who have been nominated and recognized by their peers. Welcome to the first ever J Champions Conference, where you'll have the opportunity to hear from 24 different Java champions. There'll be sessions today, tomorrow, Monday, and Tuesday. That break in the middle on Friday is for DawsCon, where we've managed to sneak in some Java champions to the speaker list as well. We look forward to seeing you at many sessions at J Champions Conference. And be sure to put your questions in the chat so we can ask our speakers during the live Q&A. To kick off the conference, we have Mark Heckler, who is a professional problem solver, Spring developer, and advocate at VMware. Take it away, Mark.
Thank you very much, Jean, and hi everyone. Let me switch back to my slides here. I only have a few, as you can see, but I've got a few. So I thought I would try something a little different this time because normally I'm pretty high energy, but I've only had half a pot of coffee this morning. So I'm gonna just ease into this, and hopefully I won't blow anyone out of the water, with too much energy and caffeine just yet. But if you have coffee, bring it, drink it, and thanks for coming. So I have I've started doing this kind of thing called Spring Boot Omakase. If you're familiar with what an omakase is, it's a term, it's basically chef's choice. I guess everything goes back to food, doesn't it, at some point? So an omakase is a chef's choice. If you go into a nice restaurant and you say, just bring me what chef recommends, what chef would like to share with me today. Sometimes that means some classics, some things that are very, very well regarded, that are favorites, and sometimes it's just stuff that the chef wants to try out and share because they're excited about it and it's something kind of new and different. And that's kind of what the omakase is, So today's Spring Boot Omakase is system scalability, or as I like to say, taking it to 11. I'm also a TV and movie buff, so if you don't recognize that reference, shame on you, but I'll let you research it and check out Spinal Tap. This is Spinal Tap, and so on and so forth. So again, as Jean said, my name is Mark Heckler. I'm a Spring developer and advocate with VMware now. VMware and Pivotal acquired Pivotal after spinning it out a few years earlier. So we're still the same basic team. We're still doing the same great stuff with the same great technologies and the same amazing community. It's just now labeled VMware. So that's awesome. We actually have a lot more synergies because VMware has a lot deeper platform. So it's kind of cool. We were working with the same teams, and we still are, and it's just a little bit tighter knit now. So, but again, if you, I have an hour today. I don't want to go too relaxed because then I've run out of time still. And I do have a lot of material that I'd like to share. But if you do have questions, comments, or feedback, please do, leave them, in the chat. At the end, I'll be taking any questions, addressing any comments and whatnot. But if you think of them later, if I don't get through all of them, that's fine. Please do email me, or better yet, ping me on Twitter. As you can see, @MKHeck is my Twitter handle, and that's pretty much where I live. Email I check frequently, but not as frequently as Twitter, let's be real. So a little bit about me. I am an author. I've co-authored a couple of books. I have another book that's actually ready to be released here in a little over 2 weeks. Officially, it's early access now, but it'll be GA shortly. And I am an architect developer by trade. And as you might surmise, and as Jean mentioned, I am a Java champion. I'm also a Java 1 Rockstar, Groundbreaker Ambassador, a Google developer expert in Kotlin. So, a few honors and awards that still, even now, with quarantines and lockdowns, mean I still have to buy my own coffee and brew it. So whatever. But I do have good coffee, so life's good. Again, I'm a Spring developer and advocate with VMware. I'm also the sole creator and curator of Spring Noticias en Español. A couple of years ago, I thought, Spanish is the second or fourth most spoken language in the world, depending on who you listen to. And I do speak Spanish, even worse than English, but, people are kind. So thanks for putting up with my English today. And, as in Spanish too. So if you have Spanish language resources you want to share with the world, I just try to help amplify your voice and get the word out so we all learn better together, right? I'm also a licensed pilot. It's crazy the trust that a government organization like the FAA will place in someone if they go through medicals and written exams and oral exams and flight tests. But, it was always a lifelong goal of mine, and it took me a long time to get there. But yeah, it's kind of cool. So I do like to fly. And of course, with reduced air travel, commercial air travel, how else are you going to do it, right? So, and I do wrap that in because, you have to have interests that cross-pollinate, right? So it works. I do have a new book, as I mentioned. It's actually now available for early access, as it says, but it's only going to be early access for a couple more weeks, and then it's full on GA. It's Spring Boot up and running, and as you can see, it's out there. That is an official cover. I did actually finally get the official bird, the official O'Reilly animal, so life's good. If you want to check it out, just again, the early access, you get a week or two early access, which is unedited, raw and unedited type of stuff. But of course, then you roll into, you can either purchase or O'Reilly subscription or whatever for the full thing if you like it. But check it out for free at bit.ly Spring Boot Book. That takes you to the O'Reilly site, and you can check it there if you're interested. So the plan for the day, the plan for the morning. This is a great quote from Mike Tyson, a little violent, but everybody has a plan until they get punched in the time clock. Yeah. So, so my plan is to go through as much material as I can. If there's anything left on the table afterward, again, I'm happy to discuss this at length on sidebars, or, ping me directly, and, we'll have a chat later over coffee. So kind of the plan. In regards to the scalability edition of Spring Boot Omakase, I wanted to kind of talk about the way we typically communicate. I say we, our applications communicate with each other. So, in the typical, scenarios, what our applications do is they do the typical HTTP request response. You might think of a REST API, and that works. By and large, that works really, really well and gives no problems whatsoever. However, there are cases where that gets to be a little bit confining. And I say blocking. A lot of times we refer to it as imperative, although that's a bit of a misnomer. Imperative versus declarative comes into being, but blocking, in effect, what is the more accurate term in which we, let's say, make a request and we wait. Everything kind of stops. All processing stops until we get that response. Reactive changes the game a bit because Reactive introduces both asynchronicity and back pressure. So that allows you for processing to continue, let's say on a client type of application. And of course, it also, with the back pressure, allows you to say, look, if I request, give me all your records for orders in the last 12 months, and it's a huge, overwhelming number. If you have a client application in an asynchronous only type of environment, what can happen is you can retrieve a ton of results, so many that your client application will fall over and die, which is a terrible, sad thing. But with a reactive application, what an application can do is say, look, I can process 100 of these at a time, or 10 or 500 or whatever. And that allows that application to provide back pressure, to provide a fixed number that it can handle and slow that processing down. It doesn't change the fact that maybe your back-end application is potentially feeding an overwhelming number of responses, but what it can do is it allows that slower client to slow the pace a bit, and therefore keep up and continue processing at its availability and scalability within those constraints. So it makes sense when you need to scale to look at a reactive type of solution. Now, you can get certain performance benefits. I don't talk about those a lot, but certainly if you have the ability to issue several requests without waiting for each response, as a very simple example, if you have to hit 3 different backing APIs and each one takes let's say a second to get a response, to process and provide a response, and you have to hit 3 of them and you have to do those sequentially and block in between each one, then typically you have a minimum processing time of 3 seconds. Whereas if you can fire those off without waiting for the response and then collect the responses when they come back, all kind of concurrently, then you have a minimum of 1 second instead of the 3. So you can realize certain performance gains. However, with reactive programming, you also can actually, in its very limited circumstances, but you may actually see a slight performance degradation. And when I say that, sometimes people say, well, how is that even possible? Well, with a reactive application, you have an event loop because that allows you to not sit and block and wait on a thread. But with blocking, if you have if you have a blocking interaction between a client application and a server application, for lack of better terms, then if you have a one-to-one connection and you have literally one client, then that's the best possible performance scenario you can have, right? It issues a request, it waits. And when the server provides a response, then it goes on processing. So there's no delay, there's no other competition for resources. However, that doesn't scale, as you might imagine, that doesn't scale exceedingly well past a certain point. So at some point, a very early point, reactive does tend to increase scalability dramatically. Reactive does have reactive programming in general, and when I say reactive programming, I need to scope that down a bit more because I'm kind of painting with a very large, wide brush here. But reactive streams are really where we kind of focus, and that's because most of your scalability issues happen in the interactions, in the streams, if you will, between applications. Reactive stream specification, just at a very high level, and I'll kind of go into this more in the code because I think it makes sense as you see it. But the reactive stream specification defines four interfaces, excuse me. So you have a publisher, which is the thing that produces values. You have a subscriber, which is the thing that consumes those values. You have a subscription, which is the contract between the two. And then you have a processor, which actually implements both the subscriber and the publisher interface because it incorporates both, because that allows you to create a processor that receives values, processes them, manipulates them in some way, and then passes them on. So it's very simple, condensed API, but of course it focuses on the pain points, right? The interactions between services. At its basic level, though, reactive programming, reactive streams interactions focus primarily or are limited primarily by the protocols used, by the mechanisms used to communicate. So when you're talking about the cross network, when you're crossing that network boundary, you're very in many cases, of course, if you're basing things on HTTP-based interactions, you're still talking about a request response type of constraint. So of course we have ways around that. We have long polling, server sent events, but and WebSocket, of course, enters into things. But again, that's you with all of those things, you have certain limitations. Enter RSocket, because RSocket will allow you to build on TCP, on WebSocket, on Aeron, and cross languages, and allow you to cross that network boundary and provide back pressure across that network boundary. It's one thing to manage the pace in terms of retrieving values, but it's another to actually dictate that from the client back. And as I mentioned earlier with Reactive, you have that capability. You just need the transport to cooperate with you as well. And that's where RSocket comes in. That's a very kind of high level overview. Again, I think it makes a lot more sense when you see it in action, thus the code. So let's code. This is not me. It says it's me. This is Moss. If anybody doesn't recognize this gentleman, again, this is another TV show reference. It's a Britcom, or a British comedy from years past. So it's a bit dated, but still it's very, very apt and very entertaining and interesting. So if you haven't seen The IT Crowd, check it out. It's on Netflix, I believe, still. If not, well, that's a tragedy. So, okay. So let's go here. What I want to do is start kind of, as I mentioned, with the plan, the first part of the plan. Check time. We're good on time. What I'd like to do is start with just creating a couple of simple applications that allow me to interact between applications, as we probably do most of the time throughout our day-to-day, right? So let me take another sip of coffee, get my jet fuel going, and then let's build a couple of applications. Now, I do want to say that, of course, everybody, when they're trying to come up with a domain for any kind of applications, everybody has to kind of think through what makes sense. And rather than just kind of create some artificial constructs, which is, that works, right? I mean, we can do that. But I like to actually pull real data. So I have an application here called my Plane Finder application, which actually pulls a small device, and the device actually listens to ADS-B out transmissions from aircraft in my area. So ADS-B is automatic dependent surveillance broadcasts. And of course, every aircraft puts these out. In the US, it's required. In many other countries, the same type of thing, where it just polls once a minute and says, hey, here I am. So it gives you your full position, location, and all that information. So that's kind of nice, right? So that allows us to just see what aircraft are in the area. Now I just have a small antenna, so that allows me just to have a pretty small radius. So I don't get a lot of planes that I pick up on the, I say radar, it's not truly radar, but I do have some. So it's real live data, which I think makes it a lot more fun. But I'm going to create a couple projects here. And of course, this is a Spring Initializer. If you're not familiar with it, this is the way you can quickly create Spring Boot based projects. You can hand create them. You don't have to go here, but this allows you to get up and running faster because it allows you to generate your projects with a certain with the dependencies you choose and the capabilities for your applications you choose. It has light mode and dark mode. So blinding, back to normal. Okay, that's good. And it does give you options. So if you're a Maven developer, you can generate a Maven-based project. You can use Maven as your build tool. I'm trying to scroll in and there we go. Yeah, look at that. Okay. So if you're a Maven developer, you can generate a Maven project. If you're a hipster, you can generate a Gradle project. It's all good. You have choices. I'm going to stay with Maven today and Java, even though I love Kotlin as well. Groovy's awesome. But I'm going to stay with Maven and Java and just keep it pretty vanilla again. I'm going to use the current version of Spring Boot, which is 2.4.1. I'm going to change a little bit of the project metadata because it doesn't work otherwise. Kidding. But this allows me to just create a couple of things, a couple of applications. Call this boot server. I'm going to use jar packaging in Java 11 because it's current LTS version. And then I'm going to choose some dependencies. So I'm going to bring in the web dependency and reactive web. I'm going to be using that as well. I'm going to also, I don't know that I need to bring in actuator, but I will bring it in because, if we have a chance, great. I'm going to bring in Lombok as well. And then, of course, RSocket, because that allows me to kind of show off that take it up to 11 type of scalability. So we have some dependencies. One other thing that I want to show you with the Spring Initializer, and sometimes folks say, well, do I have to use the initializer to create Spring Boot applications? No, absolutely not. As I mentioned, you can create your own handcrafted, artisanal, bespoke applications using nothing but an IDE or even just a text editor. You can do that. Not the most productive use of your time, but you can do that. You can also use, you can go through your IDE or curl or HTTP this API, because as you can see, start.spring.io, that's a URL, but of course it's also an API. And whether you go through the initializer or whether you access that URL directly, it's the same. So the resultant output of that, the resultant project that comes out of this, is the same. It's identical. So if I started to say your cubicle mate, your office mate, but we're all pretty distributed at this point. But if your teammate likes to use the terminal window, that's fine. If you don't like command line as well, you like to come here, that's fine. I generally prefer command line, but I like the initializer because it gives you other capabilities like checking this out. So you've got the ability to explore the project. Now, I should say this doesn't generate code for you other than the main application class and main method. But what it does do, the Spring Initializer does do, is it generates your project structure. It creates your build file. It gives you your starter POMs, which in turn will give you your capabilities, the higher level capabilities, and bring in all the dependencies to provide those capabilities. So you have here, you can check out your build file. Again, your project structure, you can take a look at and see what you're getting before you even download this. So that's nice, right? But of course, you don't have to do that. I'm just going to generate this, drop this out on my desktop. It's not going to go to my desktop. Come on. There we go. Always love it when something's so simple like your keys don't work. So we'll see what could possibly go wrong, right? It's just a live demo. So save that. I'm also going to go ahead and change this, and we'll create another project today. So this is a boot client, and this is a bit of a misnomer as we go through this, but again, I'll explain that as I go as well. So we've got our boot client application. So let's see, open the boot server application. Come on, there we go. Boom, boom, boom. All right, and boot server, and we'll open this up in our favorite IDE, NetBeans. Kidding. I'm not picking on NetBeans. Well, I am a little bit. I pick on my friends, so it's all good. I typically use IntelliJ because JetBrains makes IntelliJ. They also are the guiding force behind Kotlin, and as you might imagine, the Kotlin support is quite good as a result. However, NetBeans is an awesome IDE that gives you a lot of great support for Spring Boot applications. As you can tell too, that it's not just IntelliJ, it's not just NetBeans. VS Code is supported. STS, which is Spring Tool Suite, which is based on Eclipse, and Eclipse is also well, it's another IDE. Not my favorite, but it's a solid IDE, obviously. Okay, so here's our boot server application. I'm going to start off with that. We'll just leave it at that for now. So I'm going to first go to the POM, and as you can see, we've got our POM with our dependencies as shown in the initializer. So we've got everything we need there. Yeah, so that's good. I'm going to go to my application properties, and this is where you create your sensible default for properties in your application. And of course, you can externalize your properties and in your environment, pull from your environment, but this gives you a nice place for your defaults. So if you don't override them in the environment, then your application reads them on startup and goes from there. So for instance, I want my server port to be 9090. So that's the port on which my application will start up and listen. Now, I also want RSocket, if I can spell. I want to set my RSocket port to 9091. Actually, you know what? I'm not getting to RSocket yet, so we'll just comment that for the time being. Keep this very, very simple as we begin. So, as promised. So the first thing I want to do is build an API. So I need a domain, right? So I'm going to create a class. We'll call this aircraft. And again, we're going to be retrieving aircraft or a list of aircraft, current position, aircraft positions from my device back here on the table behind me. So I'm going to, let's see, here's our domain class. So what information will we have? What properties will we have for each aircraft position that we actually pull in? So let's see. So we'll have some strings here. So we have a call sign. We'll have a registration number. We'll have our flight number and our type of aircraft. And then we'll have some things like our altitude, because of course it reports altitude, our heading, and our speed. We need to see how many knots we're traveling, 100, 200 knots through the air. And then of course we want to have our position, our lat and lon. And of course, I'm going to use Lombok because I'm a lazy developer, lazy good, not lazy bad. I just want to be really clear about that. And that allows me to now have our domain class defined very simply and easily. So that's kind of nice. I'm going to create a REST controller just to build a REST API really quickly here. So this will be our server control. I'll just shorten it, S controller. Things very tight. Now I'm going to use a web client. A web client is a tool for accessing APIs, accessing external APIs. So if you're familiar with Spring and you've used REST template in the past, that allows you to access blocking APIs. However, web client is a reactive web client, so you can use it with reactive APIs or non-reactive APIs, blocking, non-blocking. It doesn't care. It handles all of that with equal aplomb. So I'm going to just create a web client here, and I'm going to point that to my device here behind us. Actually, it's technically speaking, it's my application I have that pulls the device behind us. But let's split hairs, which, by the way, I need to start that up. So let's see here. Let's go to Plane Finder. I'm just going to start that before I forget, and then we get errors, which is always fun. So let's go back here to my boot server. So now I have this client that I'm going to have access to, and I'm going to create my API here, and I'm going to map this to, let's call this our aircraft. Let's just say one. So our one aircraft. We're just going to grab one for starters, right? So we'll return an aircraft, get one aircraft, and let's see. So return client dot get, and we'll retrieve that. We'll convert the body to a flux, and this is where the again reactive web client works with reactive endpoints or non-reactive endpoints, blocking endpoints. It's very easy to go from non-blocking to blocking, right? And I'll show you that. Might as well just go ahead and do it as I go. So we're getting back a flux or a this is very oversimplified, but it's think of it as kind of a reactive stream or a reactive list, one that's provided not once it's finished. So if you have a list of 8 items, it doesn't wait until all 8 are present to send it back. It actually sends them as they come, right? So that's a publisher, a flux in this case. And to step back a little bit farther, one of the implementations of reactive streams is Project Reactor, which of course we incorporate and use within Spring and Spring Boot, but it certainly is accessible and usable outside of Spring applications. Not sure why you'd want to do that, but you can. And Reactor takes the concept of a publisher, which returns 0 to n values, and it divides it into a couple different things, right? So it specializes any publisher to a mono, which is 0 or 1 value, or a flux, which is 0 to n values. So it could be a small collection, a small number of items. It could be an unlimited number of items over an indeterminate amount of time. And that more closely mirrors our blocking world, our imperative world in Java, where we, for instance, on a return type, we may return an aircraft, or we may return an iterable of aircraft, right? So we may return one or many. Well, the same thing goes, we felt the same thing applied when it comes to reactive streams, publishers. So you may expect to return 0 or 1 value, the mono, or 0 to n values, many values, potentially. And that's a flux. So we're going to convert what comes back to a flux of aircraft, right? And then what we want to do is just grab the first one, which then converts that to a mono. It's just one value, right? And then let's block that. Block, which again takes this down to an aircraft. So you're back to blocking. It's very, very simple. If we need reactive, we don't block. It's, yeah, pretty straightforward. I'm going to go ahead and just create another endpoint here, and this will be aircraft. Let's make this a little clearer. So 1, and then I will say all, whatever. All right, so let's do our iterable of aircraft. Why not? And get all aircraft. And this just pulls back all aircraft that are showing up at this point in time in the area. So return client.get, and we'll retrieve and we'll convert that body to a flux of aircraft. And let's do a collect list. And we'll block on that, and there we go. Okay, so let's test this. Let's go directly, just BFR direct, if you will, and we'll test this API. Oh, I don't have terminal, so let's run that. Let's just maximize it. There we go. All right, so I use HTTPy because I like HTTPy. It's cleaner than curl and gives you some really nice highlighting. Let's see what I used here. 1, right? Yes, 1. 1 spelling counts. Boom. Oh, well, what am I missing here? So let's see here. No creators like default constructor exist. Well, that's embarrassing. Oh, well, you know what? Let's do one thing here. So I need to ignore properties because I will be getting a bunch of stuff in that I'm not expecting. Because again, Plane Finder, actually, let me just switch to that. There we go. So as you can see, it actually has a lot of different fields here. Let's see, aircraft. And I'm not going to be messing with a lot of these today. I just wanted to kind of like break this down very cleanly. So there we go. So yeah, so we're up and running now. Let's see what we get. Oh, that looks much happier. Okay, so that's good. Did I say all? Was it all? Yes, it was all. Okay, good. So we see that we've got a small handful of planes that are within range of my tiny little box and antenna here, and that's nice. That's enough to work with. So that is a general API, but let's build on that. So that's our API that we're accessing our directly from of an application. So let's go ahead and build out our other one. Let's see. So go back here, And let's open up our client here. Let's build our client application. Time is good. All right. So once again, here's our client project. Once again, we have our POM. Same stuff, same dependencies. So that's a pretty quick look. Application, we don't really need to set this. What I can do is set the server port 8080 or whatever I want. But of course, the server port by default is 8080. So we can see that. So I don't need to even set that. So that's nice, right? All right. So let's go here and let's once again class aircraft. And since we're going to be consuming this, I'm going to make this an at data, but I don't need to ignore any properties because I'm not getting any extra, potentially any extra properties from my plane finder. I'm just going to interact from here to my server application, which handles all this for us. It skinnies this down to the bare essentials. So class string call sign reg flight no and type and oops class. Okay, yeah, it's like I said, I need more coffee. So we have our altitude, heading, and speed, and double, lat, and lon. And then, of course, let's go ahead and create our REST controller class, and this will be our client controller. And again, we'll use web client. Typos, web client. We'll create a client. Web client.create. And in this case, we're going to be tapping into our 9090, which is our client or our server, right? Our boot server. There we go. And let's say we do a get mapping for slash 1 AC. There we go. So this will get us an aircraft, get aircraft, and return client dot get retrieve dot body to flux once again. Actually, you know what? I'm going to do a body to mono, right? Of aircraft dot class should work. Block. Yeah, why not? Should work. So let's see. If not, we'll always think it should have. And all AC. And this returns an iterable of aircraft. Get all aircraft and return client dot get retrieve body to flux aircraft dot class. Actually, I want to collect this once again and block. All right. Let's run this and make sure that we can get from client application to server application, and then we'll take it from there. And again, this will start up on 8080. So in this case, it's HTTP typing helps 8080/1AC, wasn't it? Sorry, 1AC. That's one of those mornings. Let's see, not found. Localhost 9090. Oh, one and all. Oh, well, that makes a big difference, right? Because I just point to the base URL, but of course, in order to get to what I need to provide a URI here, and we'll add on our, what was it, 1AC or just AC? Let's find out. And it's /1 and /all. Consistent naming would help, wouldn't it? Let's see, one, and then same thing here, -URI, all. All right, let's try that again. Should work a little bit better when I'm actually accessing the right endpoints. Seems happy. That seems happier. So let's see, what was the other one? All AC, all AC. Oh, that's much better. Okay, so we've rather quickly, really, even with a couple of forgotten URIs, we've actually created a couple of applications that interact. And actually, we're tapping into a third application, which is providing our live data. But our front end application, or client application, if you will, is accessing via an HTTP request response type of mechanism our backend application. So we have our client app, which is pinging our backend app. Now, I'm going to go ahead and do the next logical step, which is to convert this from an imperative, or more accurately, a blocking API to a non-blocking API. So that's going to be kind of nice. So I do want to change this over where I'm not using, as you can see, I'm using Tomcat, which any Servlet 3.1 compatible engine works for reactive APIs as well, for Project Reactor, reactive streams. But what I want to do is just go completely 100% fully reactive, and we'll use Netty, which gives us some really nice capabilities, nice bump in speed, I think. So we're going to go ahead and do that. We refresh our dependencies, and therefore we're just using WebFlux, Spring Boot starter WebFlux. So that's cool. All right, go here. And what I'm going to do is just convert this to a reactive API. Now, there are many ways you can go to a reactive streams implementation. There are many ways you can use reactive streams in your different applications, but few of them are as unintrusive as using Spring Boot and Project Reactor to do that, because it's a very natural transition. And of course, if we could convert 100% of all of our applications in one fell swoop to use reactive APIs, that would be wonderful. It's not the reality we live in, but it would be wonderful, because let's face it, even if we have the ability to convert some of our applications to that and take advantage of the scalability that gives us, we're not going to be able to convert everything overnight, nor should we, right? There are going to be certain things that are working just fine. They're scalable enough, and that's fine. But what that indicates is that we have a necessity to kind of operate in both realms for some time to come, both as developers and as for our systems as well. So Web Client, as I mentioned earlier, handles that in terms of it will allow you to interact with either reactive or non-reactive blocking APIs. But when we haven't really even addressed the mental headspace, right, for us developers, because most of the time we're going to be working on existing applications, and those existing applications, again, are still in that blocking world. So if we have, let's say, 20 or 40% of our time that's spent in building reactive applications, but we still have a significant amount of time in non-reactive applications, if you use a library or an approach that actually causes you to completely throw out your thinking processes and switch gears, there's some cognitive costs involved, right? So what the Spring team wanted to do is make this as frictionless as possible to switch between them. And it really, truly is, because instead of returning an aircraft, as I kind of hinted at earlier, we're going to be returning a mono of aircraft, right? So this is 0 or 1 values, which is basically what an aircraft is, right? You either get one back or you don't. But in this construct, we're returning a publisher, which has 0 or 1 aircraft. There's really not much different. And again, we just take off the block, right? So that's it. It's so simple, and it keeps things very consistent. So if you need to switch gears mentally between projects that use reactive APIs or not, it's very easy to switch back and forth and be immediately productive as a developer. Here we have an iterable. We're going to change that iterable, which is 0 to n values, right? And we're going to return that to a flux, which is 0 to n values, a publisher. We don't need to collect that to a non-reactive list. Oops, wrong key. So let's try that again. Now let's just do it the hard way, right? And we don't need to block. We just return that flux. Simple. All right, I'm going to go ahead and restart this. And then I'm going to go back over to my client, right? And my client, I'm not going to change anything just yet. I'm just going to leave that running. And then let's go out here and let's try to access our client endpoints once again, 1AC. Oh, am I not up and running just yet? Oh, you know what? Let's see what I might have missed. Terminated with an error. Hold on. Yeah, clearly I need more coffee. All right, let's start this again. In fact, let's go direct. Let's just see what we get by traveling direct. All right. Let's go to our 1 from 9090. And we're having some issues there. So am I not... I guess I should go check Plane Finder to make sure Plane Finder is up and running. And it's not. Okay, well, that explains much, right? Not sure what happened, why it crashed there, but yeah, let's go ahead and run that again. Yeah, everything's running there. So let's try this. Restart. And 1 is the correct endpoint. Let's try that. Oh my goodness. Okay, so we're doing great here. This is always fun when this happens. Actually, it never really happens. So let's see. Live troubleshooting. This is cool. So let's go to our Plane Finder and see what the error is here. Value too long. Oh my goodness. Well, see, once in a while, I defined all this stuff, and they've actually expanded the number of characters that this can accommodate. So that's that's something. So the registration number is actually increased. Okay. So let's check this out. And the registration is 7, and now it's saying that it actually needs 8. So see, they keep increasing the number that that this actually will accommodate. So let's see if we can do this. Let's just expand this dynamically. This is good stuff. This is actually real life stuff here. So that's cool. So, yep. All right. So let's go back to our server. Let's restart that. All right. So let's see what we get here. Oh, look at that. Okay. So yeah, data can only be cleansed to the extent that you're aware that valid values. But as you can see here, we've got a registration number, which is now well, actually, that's 8. So there you go. In the past, it's been limited, more limited. It was 7. Before that, it was 6. So apparently, we just keep expanding, which is interesting considering we're not really flying that much. But go figure. Okay, so we're up and running with that. So everything, I guess I should test the all on the back end. That works. So let's go back to our front end application now. And we'll see what we have there. I'm going to go ahead and restart that so we get things cleaned up. And then I will go back here and let's just test that. So 1 AC once we get started. Never a dull moment in live coding. Even just bad data can trip you up. So we've got 1 AC, that works. What was it? All AC, right? All AC. Boom. And we're down to just 2. So small Beechcraft and a small Cessna. Quiet day. Okay, so we're up and running here. We've as I mentioned, I converted the back end. Let me go back here. The back end to a reactive API, but my front end application, my client application, is still not right. So we're converting from that those reactive streams publishers to a blocking API with standard types like aircraft and iterable of aircraft. So let's go ahead and change those over to. We might as well. Time's kind of tight. I'm actually just going to skip ahead a little bit because it works the same way if we convert this to publishers as the backend. So I'm just going to skip this step so I don't run out of time. I do want to allow as much time as possible for the bestest stuff. So let's go ahead and just skip ahead. I'm going to go ahead and comment out my web, just the Spring MVC dependency here. So yeah, so let's go ahead and get rid of this, and we'll convert this. Yeah. So what I'm going to do is streamline to the maximum extent possible here. I'm going to go ahead and change this from a REST controller here. I'm just going to make this a controller, which allows me to change some of these endpoints. I'm not going to need my web client, right? And I'm going to change some of these endpoints from a get mapping, because this will no longer be a REST API, to a message mapping. And that's going to allow us to use RSocket. And I'm going to use the message mapping here. Actually, I don't even need this on my client. What I want to do is is just create a post construct method. So I can, we'll keep it really simple. So I'm going to do this, and we're going to pull our back end using RSocket. Now I do want to stop for just a second and pull up RSocket, because RSocket has different interaction models. And as you can see here, and this is of course the RSocket site, it's an application protocol providing reactive stream semantics. It builds on reactive streams. It specifically builds on Project Reactor, which is really, really handy, right? And RSocket was created by a collaboration of companies like Netflix and Facebook and Alibaba and Pivotal at the time, now VMware. And it allows you, again, to bridge that network boundary and provide the reactive stream semantics, including back pressure across that network boundary. Now, in many cases, you'll have the typical request response interaction model, and that's fine. That works. So you send a request, you get a response. You also can have a request stream interaction model, which you send a request, you get maybe a large number of responses, right? A finite stream of many, as they say here. Fire and forget allows you to send off something, a packet of data, if you will. That's probably the bad terminology, but it sends something out from the client to the server and doesn't expect any kind of response from the server. And I have to say, just to back up just a bit, once the initial connection is established, there is no client and server in terms of semantics between the two applications. They're peers, right? So communication can be initiated from either end or continued from either end. So there's no longer this, the client has to make a request in order to get anything of meaning from the server. It actually can go both ways and simultaneously, because that brings us to our next one, which is a bidirectional stream, a channel. And as it says here, it supports session resumption. It gives you a lot of capabilities across different underlying transports in various different languages, as you can see here. So that's kind of where I'm going to be going with this next. So I'm going to just create a void method here. And what I need to do actually before I do this is to get an RSocket requester bean, right? So what I want to do is requester. And based on having RSocket on our class path, what Spring Boot will automatically do with its auto config is provide a builder, right? And I want to return our builder.tcp. I'm going to use TCP for my underlying transport initially, right? And I'm going to be accessing localhost at port 9091 was the port that I set up, or will be setting up, I should say. If I go back over to my server and the application properties, I'm going to be operating on my RSocket server on port 9091. Let's go back to our client. Okay, so we have our RSocket requester. I'm going to now inject that. So private final RSocket requester. And to do that, I can use field injection, which is a terrible idea. I can use constructor injection and create my own constructor, or I can just, since I'm using Lombok, be lazy about it and have Lombok provide that for me in a constructor with, a parameter for each member variable here, which is just this one, right? So I get that via a constructor. So I'm going to just change this to requester.route. And my route, in this case, I'm going to create a route called request response. And I'm going to just get rid of that. I'm going to provide data, and I don't have to provide any data, but I like to because this allows me to kind of show what's going on. And then I'm going to retrieve, in this case, a mono, right? Retrieve a mono of aircraft. And let's see, I'm going to subscribe to that, and this will be an aircraft. So we'll print this out. And I'm going to make things interesting here. So airplane. And there we go. So, oh yes, I don't need to actually return that. There we go. Okay, so that's should be pretty much what I need to do at this point from my client. So let's go ahead and go over to our boot server. Pardon me. Time to get a drink here. All right, so from the back end, what I want to do is replace this controller again. We're going to be replacing this with just a controller. And I'm going to, once again, do I need that? Yeah, I do, of course, for our Yeah, I'm not sure. Let's see. Yeah, we'll carry on. All right. So again, here, message mapping. And I'm going to make this a request response. And so here we're going to return, again, a mono of aircraft. In this case, we're going to be getting, though, a mono of string. And of course, I made that a timestamp mono because I'm just sending over a timestamp. All right. So let's just get rid of this. So timestamp mono. And what I want to do here first is do on next. So I want to grab that timestamp and I want to just print that out. So let's see, we'll do a clock, spelling counts. And so we'll get our timestamp here. And then what I want to do is do a client.get once again, and I'll retrieve the values, grab the flux. In this case, it's a flux of type aircraft. Right, and then I will do a next once again, and yeah, that should do it. Okay, so let me just get rid of this, and we'll see what we get. I think I have everything in place that I need. Very quick. We go back to our client. Let's go ahead and restart that. Oh, I didn't get rid of this. And we'll get rid of that. Okay, so let's try that again. Up and running. And of course, we can see that it worked. Let me zoom in down here. I just did this very simply and just spit this out here into the log. But we see we got our single aircraft that we expected. Everything worked. Completely non-blocking reactive interaction over RSocket, which was kind of nice, right? So let's take this one step further. I should have said, actually, because what this did, this was our typical request response. So this allows us to create our request, actually request response. So it's, one in, one out. All right, so let's go ahead and make this a request stream coming back, right? So we'll do our message mapping and request stream, and this will return a flux of aircraft, get all aircraft. And once again, I'm just going to bring in a mono of string for a timestamp mono. And again, keeping it pretty simple, timestamp. Well, you know what? Don't tell anyone I did this, but in the interest of time, I'm just going to bring this down. Shh, no copy pasting, right? So, but all right. But let's see, we don't need to grab our next because we're bringing back everything. Just return the flux. Pretty simple, right? So let's go ahead and restart that. And then I'll go back over to my client and we'll build that. So I'm going to just comment this out because I want to show you now what we do. And boy, copy pasting makes me sad, but okay. Post construct. So we'll get all aircraft. And let's see, here's our route. So we'll go to, oh, there we go. Request stream. We're sending an instant. We're sending our timestamp. We'll retrieve. In this case, we're going to retrieve flux. And I'm going to just say that we're going to retrieve multiple aircraft because that's what we're going to do. So hopefully there are multiple aircraft flying in the area at this point. Oh, of course not. Okay. Connection refused. So that tells me I have something wrong over here. Oh, of course. All right. So then, actually that requires a then many. Yeah, it's much happier. Note to self, have more coffee. All right. Start this. And look at that. Of course, it works when you include all the important and essential information. Let me grab my key here so we can zoom in on that a little bit. And we see that we've got 4 different, we got a Delta Airlines, United Airlines, and then some couple other aircraft in the area. So we're getting those back. So we're getting all aircraft, and this was our request stream. Now, the next thing I want to do is a fire and forget. In order to fire and forget something, we need something to fire over, right? So what I'm going to do is just expand the domain just a little bit, and I'm going to create a weather class. So class weather, and let's see. So a private, we'll do an instant for when the weather observation was taken, and an observation. And we'll use that. And let's see. So let's go ahead and create a post construct, and this will be a void fire and forget. And we'll do a requester.route, and we'll call it fire forget. Yeah, why not? Okay. And we're going to have our data here, which is a new weather object. So I'm going to do an instant.now for our time of observation. And our observation will be skies clear. Why not, right? And the visibility is 12 statute miles. That works. And then we'll do a send, right? And do a subscribe, because when it comes to publishers, you must subscribe in order for any activity to take place. And this is very important. Seems a little odd until you think about it, but in terms of a publisher, they can generate a lot of data, and you don't want them actually just spinning and chewing up resources if no one's listening, if there are no subscribers. So this is a construct that we need to honor here by subscribing to the publisher. So let's go ahead back to our server, and we'll build out our our fire and forget endpoint message mapping, fire forget. And this will return what? A mono void, right? So we're not going to really return anything because our client is not expecting anything back, right? It's just sending something. It's firing and forgetting. So fire and forget. And again, we're going, in this case, get a mono of weather, which we don't have defined here yet. So that's why I copy pasted. So I can just do that. All right. So with our weather mono, what I want to do is weather mono.subscribe, and I'm going to grab a cloud here plus weather. Of course, that means I need to WX and south and return. And of course, you can do this many different ways. I like to just return mono empty, but you don't really have to even, again, return anything because nothing's expected. It's just, I like to keep things clean from the API perspective. So I actually should make sure that starts. And we're started. Everything is fine. Why wouldn't it be? Oh, we're tight on time. Well, hopefully I have enough time to get through the channel. I like to, let's see, so. Oh, sorry. All right, which means I probably did the same thing over here, which of course I did. All right, well, let's try that again. It's probably going to start before my other service starts, but we'll try it.
I'm going to take this opportunity to mention that the next session will be starting in 2 minutes. I'll post the YouTube link in the chat. Mark's session will continue as he wraps things up and we do the Q&A, so you get to decide what you want to do next.
Oh, okay. Thanks, Gene. So we're getting our fire and forget, our weather value. It's coming through just fine on our quote server, our other application. What I will go ahead and do is just try to get to a decent wrap-up point here. I don't want to encroach too much on the next one, but since we do have the opportunity to go ahead and continue, I don't want to cut things off and make things awkward. So I'm going to go ahead and wrap up. If you need to leave, that's by all means, please do so, but we'll go ahead and just charge forward because why not, right? So this is where it really gets fun, really, because what this allows me to do is set up a bidirectional channel. So I'm going to just create a void channel method, right? And I'm going to just create a couple of things here. So I'm going to create a, yep, that'll work. So a list of observations. So equals, and I'm going to do a list of, and let's say, so we've got different observations. So sky is clear and 12 statute miles. So visibility is 12 statute miles. And then of course we may have one that's overcast at 080, so 8,000 feet, and visibility, let's say 3 statute miles. And then we've got few at, I don't know, few at 20, 240. So flight level 240 and visibility of, let's go crazy, half statute mile. Why not? Let's make it totally unrealistic. Okay, so we've got, I'm going to create a random variable. So new random, because random is fun. And then, excuse me, what I want to do is define the route here. And I'm going to point this to a route called channel. I'm going to send a data, and I'm going to just generate a flux with an interval of, let's say, 1 second, right? So there's my interval. And I'm going to map that. So this is just a pulse. Oops. Map that to a new weather observation. And I'll take the current time, instant.now. And then I'm going to bring in an element of obs list. We'll get that. We use random nextint, and we use the length or the size of the observation list, which allows us to just grab a random observation. And then I'm going to, coming back, I'm going to retrieve a flux of aircraft, right? And then I'm going to subscribe to that flux so I can get my aircraft, and let's just print that out. Airplane, and let's do a different airplane. Airplane. That one's ugly. Let's go with this guy. And come on, IntelliJ. And plus AC, and there. So what I want to do in this case is, it's a bidirectional channel. What I'm going to send is a bunch of data. So I'm sending once per second, I'm going to generate a pulse. And for each of those pulses, I'm going to send out a new weather observation, just a random weather observation. And then for each one of those, I'm going to wait and listen and say, hey, do you have anything for me? And from the back end, or shouldn't really even say that, they're peers once connected. Remember, from the other side, what I'm going to be getting is a list of aircraft that are currently flying, right? So that's kind of cool. Let's go back over here to our quote server, and let's create our backend channel, if you will. And this is our channel, bidirectional. And here we'll do our message mapping, and this is channel. And we're returning, in this case, a flux, once again, of aircraft, channel, and we're receiving, in this case, a flux of weather. So weather flux. Sweet. So what I want to do first is grab that weather flux and on subscribe. So when I get a subscription, what I'm going to do is just take that subscription and just say, okay, subscribed to weather. We'll keep it short, right? So, and then so do on next. So for each value of weather, for each reading we actually get, what I want to do is just print that out. So let's grab this sun. Let's make this nice. Plus weather, so we get that. And the reason I'm going to the trouble of putting in the emojis, the icons, is it actually makes it much more readable, as you can see in the log. So it actually just helps show what I'm wanting to do. And for each one of those weather observations, again, what I'm going to do is grab a list of aircraft in the area. So retrieve body to flux aircraft dot class. Yeah, so that should work, right? So let's try that. Go ahead and restart. And we're up and running, and we'll go to our other application, and we'll start that. Now, so far, and there's so many things that I want to show you other than that. Oops, I optimize imports. Yeah, I'm not sure how the imports got corrupted there, but okay. So we're seeing here, and let me just bring that over and then bring this over. So, and I should have done that before. That's so clean. So we're seeing on our one application that we're getting our weather readings coming in and our random weather readings once per second. And we're seeing that we're also getting our aircraft coming back, or I shouldn't say coming back. They're just coming over on the same channel, the bidirectional channel. So I'm going to go ahead and stop this. And I actually, in order to stop this, it's going to give me some ugliness, which I could clean up here just with the, so yeah, I mean, so I could actually go in here. You know what? It's an ugly thread, ugly trace here, but it's not a big deal. I just have a way to clean that up, but I'm not going to waste the time on that right now. What I do want to do, though, is show you that right now, up to this point, we've been using TCP as our underlying transport. And what I can do is just change that to WebSocket. Very easy. It's very simply done. And then, of course, I'm going to restart this. And to do it, change that, make that change from the other application. Change that over. Instead of using that here, I'm just going to change this over to builder.websocket and HTTP colon. Sorry, I'm in HTTP mode 9091. So, oh yes, I need to build that as URI. So URI create, and that's easily done. Let's go ahead and restart that. As you can see, everything works. So we completely changed our underlying transport and without even missing a beat. So that gives you a fair hint as far as the capabilities and the power of RSocket, Spring Boot using RSocket in order to scale your applications to crazy, crazy extents. Let me go back now and go to our last slide. And we'll wrap it up. There is more. What I'll actually do is go ahead and add in a couple more things to the code repo, and then I'll commit them. So please follow me on Twitter, and I'll just send out the link to that at the time. When I get that out there on GitHub. If you're interested in more information about the book, check it out at the bit.ly.com/springbootbook. Follow the Spring Boot Book Twitter handle that for more information as well. And by all means, again, check out the repo once I get it out there. Thanks for coming. Enjoy the rest of the J Champions Conference, and see you out there in the Twitterverse.
We have a few questions for you, Mark.
Oh, yes, forgot about the questions. Oh my gosh, thanks.
The first one is, how would you succinctly define back pressure?
Okay, so succinctly, that's always the tough part, right?
We don't know what it is, but how would you give a short definition of it?
Well, I like to think of what happens first if you don't have back pressure. So if you say, give me all aircraft positions, in this case, it's a fairly small set, right? But what if it were 1 million records? What if you had a lot of activity and I had a massive antenna with good reach? We could easily, if we had a slow client, our client, just by giving an open-ended request like that, could not be able to handle it. It would be overcome and it would exhaust resources and crash. What back pressure does, especially for slower consumers, slower consumer applications, or potentially applications on a slower connection that can't just can't keep up with the volume, I guess I should say, and can't process them fast enough. What typically what back pressure allows you to do is just say, give me 5, give me 10, give me 100. That's all I can process at a time. So don't deluge me with values. Just give me what I can handle. And once I can handle more, then I'll request more. I'll let you know that the coast is clear, and you can send me, the next however many. So it gives you the ability to manage that. I like to think of it like a garden hose and the adjustable end. So you turn on the faucet and you could get the full pressure if you took that adjustable end off your garden hose. But in most cases, you don't want to do that. You want a limited amount of pressure. You want a limited amount of water, and that allows you to manage that from the client. It doesn't change the fact that you may have a massive amount of data that you're trying to push down that pipeline. But what it does do is, in many cases, using the example of and I know I'm not being terribly succinct here, but if you have a client application on a phone over a dodgy remote connection, a dodgy Wi-Fi or 3G, 4G, 5G connection, well, 5G not so much, you don't necessarily have control over that application at all times, but what you do have control over pretty much at all times is the cloud-based application that is feeding that data. So it allows you to shift control back to the areas where you have more control.
You did actually have a succinct definition hidden in there, which is when I'm ready for more, send me more.
Okay, I just put a lot of stuff around it, so thank you. Yeah.
but the takeaway for the person who wanted the succinct explanation was in there.
Nice. Well,
the next question is, as we know, sometimes things go wrong. Are there any common patterns to deal with errors, whether they happen on the client side or server side?
Yeah, actually, and I didn't even have a chance to get into that. When I do a longer talk on reactive programming and reactive streams in general, what I like to do is point out the different, like in the Spring world, we have the Reactor Debug Agent, which allows you to get some very valuable information and leave it on in production to where it has minimal impact on performance. There are some things you can do which are very impactful on performance that you don't want to do and leave on in production environments. But Reactor Debug Agent actually gives you instrumentation that is very light. And it allows you to, whatever your application is, to see and to act on the information that's provided at the point of breakage. With reactive streams, what happens is you don't get that stack trace because, you don't get as meaningful a stack trace because you're not staying on a single thread. You're actually your scheduler is handling a bunch of different threads to optimize your resource usage. And you also have the issue of I just had a thought in mind and I just lost the thought, but you have certain complexities that aren't there in a blocking imperative world. But we're catching up on tooling now. So we have the ability to trace requests all the way through to see where things break. Oh, the subscription, because typically a publisher, again, the publishers, you can have hot versus cold publishers where they're always running versus where they just fire up as soon as a subscriber is there. But typically the focus is on those cold publishers because that's the bulk of all publishers. But what happens is things break when a subscription occurs. So you don't always see the error pop where the problem is. You see it when it's actually activated. So you need certain tools in place to allow you to see where and trace where that issue occurred, where it really occurred. And that's where things like Reactive Debug Agent help dramatically.
Speaking of tools, we had a shout out to Spring Source Tool Suite in the chat for creating new projects.
Yeah.
What's the benefit of that versus the way you created the project or vice versa?
Yeah, I mean, Spring Tool Suite or, okay, let me back up. You have the ability to access the Spring Initializer, which is what I showed, via the web page, right, or via browser, or you can access it via an API. So whether you use curl or HTTP, or you access it via your IDE like Spring Tool Suite or IntelliJ or NetBeans, or Visual Studio Code also has integrations because we use a language server to provide those. It's the same thing. So you're still getting all the same capabilities and you get the same resultant project that's generated and pulled down and opened in your IDE. So it's identical output. It's identical outcome. The difference is how you prefer to consume it, really.
Okay. And what I believe is our last question is, why do we need another programming model for reactive? Is it because of scalability or something else?
If you don't, that's great. And if you look at the Spring framework documentation in terms of for reactive programming versus non-reactive or blocking APIs, you'll see that, I mean, the recommendation isn't, and the expectation isn't that everything has to go reactive. That's game over. Because let's face it, if you have some applications that are working fine, you're having no scalability issues, you don't necessarily need to switch over to reactive. However, it does give you a lot more tools in your tool belt to scale more dramatically. So if you have, situations, and I'm talking systems holistically, not just an application, but if you have a system of systems that you're having some scalability issues, some problems in terms of, vastly changing demand, what reactive does, reactive streams, the reactive streams constructs do is give you the ability to handle that scalability, that wicked scalability. When you add RSocket onto that, again, it crosses that network boundary. So instead of working within an application and better utilizing those resources, or even across applications to some extent, it allows you to kind of take that to the full extent, crossing the network boundary across multiple applications. So if you don't need the crazy scalability, you can always stop wherever you need to stop. That's perfectly fine. But what we want to do is build the constructs that build on each other nicely and that allow you to switch between them with very little friction, mental friction as well as system friction. And I think, as you can see, it's very easy to switch between them with minimal changes to your code. And Spring Boot's auto config and the things that you provided as far as the guidance to do that makes it pretty simple.
Cool. Thank you, Mark. And thank you for kicking off our conference.
Thanks so much. Thanks for having me.
Bye. Have a good day, everybody. We look forward to seeing you at more sessions.